This is tutorial 7. In this tutorial we will break our model and then try to fix it. When we created the flanged pulley in tutorial 5, sketch 001 for the holes was mapped to this face. First we will edit the sketch of the pulley profile, which is named sketch. In this tutorial, keystrokes are shown here. Change to the Part Design workbench. Select the Model tab, then expand the features in the hierarchy tree. Select Fillet, then press the spacebar to toggle visibility to off. Right-click on Sketch, then select Edit Sketch. We will zoom in a little. The holes forming the spokes are mapped to this face, which we will taper, breaking the model. First we will delete this vertical distance constraint. Now we will delete these horizontal constraints. Change the constraints filter so we can see all constraints. When we select a constraint, it turns green in the 3D window. Pressing delete deletes it. Repeat to delete the other horizontal constraint. Delete this line by selecting it, then pressing delete. Define this distance with the vertical distance constraint. The distance is already 57.15 mm, so click OK. We will replace the deleted line with two equal lines, after moving the constraint out of the way. When the segment is vertical, this symbol means the vertical constraint will be applied to that segment, saving the need to apply it later. We repeat this for the second segment. Set the segments equal to one another with the equality constraint. We use the coincident constraint to constrain the endpoints of our segments onto those of our model. Now repeat for the other segment. This error message tells us that our model is now broken because this face has changed. We will delete this segment, and replace it with two of equal length. Notice the vertical constraint symbol, again. We add the other segment. We set the lengths equal to one another, with the equality constraint. We constrain the endpoints of our new segments onto the existing endpoints of our model. Now repeat for the final segment. Connect the two midpoints with a horizontal construction line. The new line is so nearly horizontal that the horizontal constraint will automatically be added. Here we see that the endpoints have changed to yellow, which means they are pre-selected, and the endpoint of our horizontal line will automatically be constrained coincident to them. Notice that these points are not coincident. We will need to fix that later. We will change our line to a construction line. The blue color indicates this line as a construction line. We will set these 2 points symmetrical to it. By applying the symmetry constraint, Next we will set the distance between these 2 points at 9.525 mm with the vertical distance constraint. We will affix these points onto one another with the coincident constraint. Select each point and apply the constraint. With our model fully constrained, we can close Sketcher. We can see that our model is broken. Because Sketch 001 was originally mapped to this face, parallel to the x-axis, but now that face is tapered. We toggle visibility of Sketch to off and toggle visibility of revolution to on, by pressing spacebar while each is selected. We map Sketch 001 to this face of the previous feature revolution. By using the Map Sketch to Face tool. First we select the face onto which the sketch will be mapped. Then we select the Map Sketch to Face tool. Select Sketch 001 from the pop-up menu and click OK. The sketch is fully constrained, so we close Sketcher. We see Sketch 001 is now fixed. But Sketch 002 is still broken. Remember, we are looking at Sketch 001, which is mapped to the feature revolution. Now we will look at Pocket, which is the feature created from Sketch 001. We will center the view before toggling the feature polar pattern to visible. This looks okay, so let's look at Pocket 001 because Sketch 002, from which it was created, is broken. We can see our pocket does not go all the way through. But from the Data tab, we see the pocket should be through all. Select Pocket 001 and press spacebar to toggle visibility to off. Now select Polar Pattern and press spacebar to toggle visibility on. We will map Sketch 001 to this face of Polar Pattern to see if that fixes our model. Select this face. Then select the Map Sketch to Face tool. We want to map Sketch 002. Here we see that Map Sketch to Face did not work. We also see Sketcher Solver tells us to delete a redundant constraint. Change the constraint filter to see all constraints. Let's delete a constraint as instructed by Sketcher Solver. Select the constraint, then press the delete key. All the other constraints were deleted too. We won't try to salvage the sketch, so let's close Sketcher. We will delete Sketch 002 and everything dependent on it. To see those dependencies, we use the dependency graph. Here we see that Philip and Pocket 001 are dependent on Sketch 002. We will delete them starting with the most recent. Select Philip, then press the delete key. Repeat for Pocket 001 and for Sketch 002. To see our model we will change tabs. From here we just retrace our steps from Tutorial 05 to rebuild our model. To make the keyway, start by creating a sketch, map to this face. Sketch a rectangle. Create an edge link to external geometry. And constrain the lower corner of our rectangle onto the edge we just made. Create symmetry of our keyway about the y-axis. Constrain the horizontal length to 6.35 mm. We'll move the constrained text so we can read it. But it's difficult to select because it just happened to fall on the bottom line of our rectangle, so we'll just delete the constraint and add another at the bottom later. Use the vertical distance constraint to set the side to 3.175 mm. We use the horizontal distance constraint to make the keyway 6.35 mm wide. With our sketch fully constrained, we close Sketcher. Let's change the view, to see our upcoming pocket better. From the Tasks tab, select Pocket. Instead of the default 5.00 mm, we will pocket through all. We will fillet the spoke edges. Select all the edges. We are not in Sketcher, so to select multiple items we need to press the Control key. When all the spoke edges are selected, click Fillet. We will use the default 1.00 mm, so click OK. And we have our fillets. Finally, we will chamfer the keyway and hub hole. Press Ctrl to select multiple edges. When the last edge is selected, click Chamfer. We will use 1.00 mm, so click OK. We will examine our model. No more red exclamation points here. And the features are OK, per the dependency graph. Thanks for watching.